This video is about even and odd functions. If we look at these pictures, that can kind of give us an understanding of what even and odd functions look like graphically. When we look at x squared, x to the fourth, x to the sixth, and any other basic parent function that has an even power, what we see is that the graph has reflections over the y-axis. So if I take a look at the y-axis as sort of a mirror, what you can see is each of these functions would have points that reflect perfectly over the y-axis. So, for example, this point on y equals x to the sixth reflects perfectly over to the other side. Likewise, for parent functions that are odd, like x, x to the third, x to the fifth, if we have an odd power parent function, that tends to rotate perfectly over the origin. So what we would have is, for example, this point, 1 point something comma 4, rotates perfectly to negative 1 point something comma negative 4. So it rotates 180 degrees about the origin. Another thing that we need to know before we get too deep into this video is that even powers eliminate negatives. So x or negative x times negative x would become positive x squared, because a negative times a negative is a positive. And likewise with to the fourth and to the sixth. But if we have the situation where we have negative x to the third, let's say, negative x times negative x becomes positive x, but then there's still another negative that's floating around in there. One other thing to keep in mind when we have these is when we look at something like negative x squared, that's not the same as negative x squared. So this would be negative x times negative x, whereas this one is negative x times x. So that's just important to remember from our previous math classes. And then when we just look at one more thing that we may want to remind ourselves, if we have negative, or the cube root of negative x, that's the same thing as negative cube root of x. It kind of works in a similar way as the odd powers do. But when we have an even situation like the square root of x, there are domain restrictions. So I can't just say that negative square root of x is the same thing as the square root of x. It's not similar. They are not equal to each other. That's because they have domain restrictions. Like in this particular case, you can only have a domain of the negative numbers, whereas in this case, you can only have a domain of the positive numbers, and 0 is actually in both domains. So now let's go to the actual notes. Even functions are functions that behave a lot like these basic parent even-powered functions. They have symmetry over the y-axis. And odd functions behave very much like on the previous slide that I had, where they have symmetry by rotating around the origin. So a function that is even reflects symmetrically over the y-axis, and a function that is odd rotates symmetrically about the point 0, 0. So a function is even if for every number x in its domain, the number negative x is also in its domain, and f of negative x is equal to f of x. For odd functions, that means that f of negative x must equal negative f of x. In even functions, the point x comma y being in on the function, so if f of x has x comma y, f of x must also have another point. It must also have negative x comma y. So if I substitute, like for example, y equals f of x is the function. If I substitute negative x into the function, I get y back. So these 2 points must be on the function. In this odd situation, if on the function I have the point x comma y, there also must be another point on the function, negative x, negative y. So the thing gets rotated 180 degrees. It ends up in, if it was in the first quadrant, it ends up in the third quadrant with the exact same x and y type of values. Algebraically, what we would do is we substitute negative x in for x in the original equation. If you simplify and it's the same equation as the original, the function is even. And if you simplify and it's opposite of the original equation, then the function is odd. You can see that number 1 looks like if there's any sort of symmetry, it would be rotational, but it's not quite that simple. We have the point 1, 0, but we don't have the point negative 1, 0. So notice the point negative 1, 0 is not on the graph. So let's show what we do to test for this. F of negative x, so we basically just substitute negative x anywhere there was an x into the original equation. Now, remember that when we have an odd power, we can pull the negative out. But when we have an even power, negative x to the fourth just becomes x to the fourth. Our test is this equal to f of x? And f of x was x to the fifth minus x to the fourth. It is not. Is it equal to the opposite of f of x? So the opposite of f of x is negative x to the fifth plus x to the fourth. It's basically changing the signs of everything. It's not equal to that either. So therefore, this is neither. Number 2, graphically, it very much looks like an even function. It looks like it flips over the y-axis. Let's double check. So if we have f of negative x, that's negative x to the sixth plus 1. That's the same thing as x to the sixth plus 1, which is the same as the original function, f of x. So that means that's an even function. If we look at this graphically, it looks like an odd function. So the reason we can think it looks like an odd function is each of these points. So for example, this point that's at a little bit less than 1, comma 2. If we look at it, it looks like it comma negative 2. It looks like it rotates perfectly over to the other side. And that seems to be the case for all of them. So what we will do is we will say f of negative x, the cube root of negative x over negative x squared minus 1. That simplifies to be the opposite of the cube root of x over x squared minus 1. This is exactly equal to the opposite of the original function because the original function was x cubed, or the cube root of x over x squared minus 1. And what I can do with this negative is I can rewrite it out in front because only the numerator is negative, the denominator looks the same. So it looks like negative cube root of x over x squared minus 1, and these are opposites. So this is an odd function. Number 6, this also looks like an odd function because any point here is exactly rotated 180 degrees about the origin. But let's double check. F of negative x in this case is negative x over the absolute value of negative x. That's negative x over the absolute value of x. The reason we know that the absolute value of negative x is equal to negative x is whatever we substitute into the absolute value, like if I substitute negative 3 in for x, it does not matter whether I substitute it into either one of these. It ends up being exactly the same. So that means that this is exactly equal to negative x over the absolute value of x, which is the opposite of f of x. So this is also an odd function. The graph definitely does not seem to mirror perfectly over the y-axis, and this point does not match up with a point over here. So that one looks like it's not going to be either. G of negative x is equal to negative x cubed over 3 times negative x cubed minus 1. And that simplifies to be x cubed over negative 3x cubed minus 1. So this changed and that changed, but this didn't change. If everything totally changed in both the numerator and the denominator, it would actually be the exact same function as the original. And if only the numerator or only the denominator changed, then it would be a total opposite function. But in this case, it's neither. Let's look at it from an algebraic perspective real fast. Negative x plus the absolute value of negative x is equal to negative x plus the absolute value of x. And that is not the opposite, because both of these would have to be negatives. And it's not the same because it's clearly not the same. So that means both of these functions at the bottom are neither even nor odd. Last thing that we're going to talk about, is it possible for something to be both even and odd? If we have a graph and we have the point x, y, in order for it to be even, it would have to mirror over to negative x comma y. In order for it to be odd, it would have to mirror over to negative x negative y. It can't be both even and odd at the same time, because in that case, if both of these were true, then you would have 2 points on the same function that would have the exact same x values, and they would have different y values. That would not be a function. Therefore, this is not possible.